let's talk a little bit about the class. Today's goal of today is to introduce what the course is going to cover, and then talk about the very first topic, which will be discussing an overview of Android and some of the key layers in the software stack. I'll show you a little bit about how to install the software. I'll show you the course website where we'll keep track of all this stuff and talk about some of the projects we'll be doing throughout the course. So the purpose of this course is to do a couple things. One is to obviously learn more about mobile devices, mobile programming, particularly focusing on systems programming. This class is going to do a little bit of stuff with user interfaces because you're going to have to interface with the phone, obviously. But the main goal is to focus on the systems programming side of the house. And I'll talk more about what that means. That's going to involve primarily things related to concurrency, running operations in the background, as well as things that are related to networking, so communicating with other phones, other servers, other cloud devices, and so on and so forth. And the focus for all this stuff is going to be Android. That'll be the main platform. We're going to be developing a bunch of different applications. We'll start out the course with probably 4 or 5 assignments where I give you the spec and you implement against the spec, and then I'll review your work. Those of you who've taken CS 282 or 251 will know the drill here. And then we might have a project towards the end that may be either an individual project or a group project, still TBD, and the goal of all that is to get people to try something more interesting, bigger, broader, and so on. Some of you are going to be taking, or I know some of you are taking CS 279 or 278 with Jules White, and so for those of you in that class, we'll try to figure out a way that the projects we do here and there can kind of dovetail on each other, and you'll see why. You'll learn more about why that's a good thing when we get further along in this course and that course. And as usual, there'll be lots of programming. So I'm the teacher. We'll be doing office hours for this class up in FGH 226. You should all be familiar with that if you've taken 251 before. In fact, for those of you who have a 251 background, we'll be having some of the same people involved. We're also teaching 251 this semester, and so that particular room is going to be a bit of a shared resource. We're trying our best to make sure that we coordinate things so we don't have office hours from the different classes at the same time, and that's going pretty well. My office hours, as usual, will be the 2 hours before this class, so from 1 to 3 upstairs, and we'll have a pretty good range of people covering the other times as well. I'll talk about the other TAs. For those of you who've taken 251, I'm pretty much available all the time through email. So send questions and comments and stuff, and I'll address them. If I get ambitious, I'm co-teaching CS251 with Christoph, and he's leading me into the brave new world of social media tools. So we may have a Piazza mechanism for 282 as well. Some people seem to like that, and that's probably what we'll do. The TAs and graders, people who'll be helping you out with office hours and questions, are going to be Nick King over there, and Nolan Smith, who's back there, and Lane Kelly, who is out of town, but he'll be back soon. And I've worked with everybody here on various things before. And there's the website for the course. Let me go and show you the course website. This is what it looks like. And you can see that we already have an assignment that's due Monday, and you'll find out more about that in a second. It's a very straightforward assignment, hopefully. And then we also have the slides from the course overview that I'm going to be presenting here, so you can download those as well. And as we put more lectures, more assignments, they'll go up on the web page. You can always get to them there. All right. So in this class, you should be able to do the assignments in pretty much whatever platform you want to use. That's one of the great things about Android. You're not limited to using one platform. You can use Linux, you can use Windows, you can use Mac OS, should be pretty open-ended. As always, unless told otherwise, you have to do the work individually. Group projects are an exception to that, of course. I'll talk more about that later. Much like we've done in other classes, the way it'll work is you'll submit the assignment, I'll take a look at it, give you comments back, and then you guys have a week to address the comments, and then you'll submit it and it'll be graded at that point. And the grading, no real surprise there. There's some amount for having your program actually work, which is always a good thing. And then there's other stuff for how you structure the program, how well you document it, other kinds of things that make the code easier to understand and easier to grade and evaluate. In this class, unlike CS 251 this semester, we're going to do the thing where if you're you can't submit the work after 2 days. Up to 2 days, you get 5 points off out of a possible 100 points for each day the program is turned in late. Try not to fall behind. In teaching this class last semester, or last year, I taught it last fall, there were a handful of people who got way behind and never really caught up. So if you've taken 251, you know what that feels like. We'll have weekly quizzes and a comprehensive exam. The quizzes are there really just to make sure you're following along with the lectures. They'll pretty much be straight from the material we cover in the lectures. Once again, anybody who's taking 251 loves quizzes because they're so much fun, but it's a good way to make sure you're not falling behind. Here's basically the weighting of the pieces of the course. So programming projects, 40%, quizzes, 40%, final exam, 10%, which gives you a sense of how big the final exam is. It's just basically a quarter of all the quizzes. So if we have 10 quizzes, then we would have a 3-page final exam or something like that. And then there's also another 10%, which is class participation. This is intended for a variety of purposes. So one purpose behind class participation, of course, is to get people to speak up, which is great. The class is way more interesting when people are involved. When we taught the class last year, we had a bunch of folks from ISIS taking the class who were doing work on mobile phone operating environments and middleware and so on, and it was great because they were really involved and we had lots of discussions. A lot of the other students, regrettably a lot of the grad students, just sat there like a bump on a log, never said a thing. That wasn't as much fun. So basically the best way to get good class participation marks is to make sure I know who you are. When it comes to the end of the semester and I'm looking down through the thing, and there's certain people who don't show up for class, that's an automatic bunch of deductions. They're the people who just sort of sit here and fall asleep, that's deductions. So be here, be engaged, be active, and make sure I remember who you are, and come to office hours and ask lots of questions, and you'll do fine. Okay, some other ground rules: submit programs on time, do work on your own. There's a funny cartoon here that seems germane. It says, while outsourcing is a common business practice, you may not outsource your research and homework assignments, Fletcher. So we can't outsource everything in life, even though sometimes we'd like to. No laptops in class unless we're doing something that involves laptops. Next Monday we're going to sit down, and anybody who has not gotten the Eclipse stuff installed, we'll do that in class, and we'll also talk about various tools. We'll also talk about other ways of programming Android besides using Eclipse. Eclipse is pretty cool. It's integrated nicely. The downside is that it's a real memory hog. So unless you've got a lot of RAM and unless you have a really fast disk and a big disk, you can have some problems with it kind of thrashing. Or at least older versions had that problem. I'm not sure whether it's such a problem anymore. So if you have a powerful computer, then Eclipse is probably for you. If you don't have as powerful a computer, I'd recommend you use something like IntelliJ or the Android, what is it called? Android Developer Studio?
Just Android Studio.
Android Studio. There's something else coming out in the not too distant future. I think it's already out in a beta mode, which you can use called Android Studio. And that's probably the thing ultimately to use, but it's a little bit too flaky now to use. We'll have guest lectures from time to time. I travel periodically, or there'll be people here who have other things to say that are interesting. Scott, for example, you want to say a few things just briefly, no pressure, about that, as I guess it's now being called?
Sure, yeah. So, hi everybody, I'm Scott, and I'm the president of the Vanderbilt Applications team, which is a student group here at Vanderbilt that develops software applications for really popular platforms like Android, as well as other platforms like iOS, and getting cool stuff like Unity, 3D game development, and web development. So we're looking to get a bunch of you guys involved with that, and if you're interested, you can talk to me afterwards about what the logistics of the club are. So yeah, we'd love to have you guys.
And I think, how many other people here in the class right now have done something or other with VMAT, VAT, Vandy Mobile, one time or another? Okay, so we have about 5-6 people. I highly recommend getting involved. It's great for a lot of reasons. Number one, you get access to people who are really good at this. Another thing you get access to are a lot of people around the campus and around town who are looking for talent in this area. Do you want to say just a thing about the kinds of internships or consulting opportunities or other things that have come people's way?
Yeah, I mean, we get a ton of people always emailing emailing our listserv, asking for talent, asking for students to do contract work or for full-time opportunities, internships. If you're looking for something in the industry, it's a really great way to get connected with both the national community and the surrounding communities for doing development. So it's really great. Yeah.
And it's worth pointing out, as Scott was just saying, obviously most of the people posting are around the area, but the experience people have built up by being part of the group has enabled them to go off and get internships and jobs at all the national places too, right? So
Absolutely.
Apple and Google and other places. We had a student a couple years ago, Aaron Thompson, who went off to Apple and is working on a lot of cool projects, and other people have gone to other places based on what they've done. And some people have gone to grad school and done cool stuff. So it's definitely worth looking into. Another thing, just real briefly along those lines. So one of the other big focal areas right now in the engineering school in general and in the CS program and CompE program in particular is access to entrepreneurship mentoring. So this is one of the things that makes Vanderbilt kind of special, and the kind of thing we're providing with the students here is the ability, if you're so inclined, to get involved with various groups around town who mentor people who want to start companies or want to be part of companies that are startups. And we'll talk more about that. There's lots and lots and lots of opportunities in that space. So be in touch with me if you're interested in that. There's actually a donor in the ecosystem, the Vanderbilt ecosystem, who's donated a big chunk of money so that Vanderbilt students who want to go down to the Nashville Entrepreneur Center can go down there and get help. And that means mentoring from other people who are entrepreneurs, successful business innovators, venture capitalists, and so on. So if that's something that would interest you, let us know. The Vandy applications team, or Vandy Mobile, is also very well plugged in. We have lots of alums over the years who've gone through these various accelerator and incubator programs who also had a background in these kinds of technologies. So it's pretty cool. So make sure that there's lots of help. Come to office hours, ask questions, post either send them to me and I'll repost them anonymously to the class mailing list, or we'll use Piazza and do the same kind of thing. We'll have a mixture of lectures and programming exercises. One of the things I try to do as much as possible is, after we do an assignment, or actually while we're working up to an assignment, I'll show you example code. We'll walk through the code. I'm a big fan of learning by seeing how it works. And one of the nice things about Eclipse is how easy it is to do that. Even if you have an Android phone, this is actually an HTC One. I also have a Galaxy Nexus. These are pretty good phones, high-end Android phones. If you have a phone like this, it's fantastic, because that'll allow you to be able to download the code you write, the jar files and so on, into the phone as packages, and it runs really fast. It gives you the total experience that you expect if you were using any other kind of Android app. If you don't have a phone, not a problem. All the development environments come with emulators, and we'll also give you some tips on how to set up the emulator so it runs blazingly fast if you have virtualization support on your hardware. And we'll talk more about that a little bit more today, and then more about that next time. When I did the class last time, I didn't use that, and it was painful trying to run the examples on the emulator. And once I installed or configured the hardware accelerator, man, it's really fast. So it's almost as fast as running it on the phone. But either way, you should be fine. And as we go along towards the end of the class, people get a chance to give presentations about what they did, their applications that they wrote. So we may do some of that towards the very end. And we'll take a look and see how it goes. There may be other things that crop up along the way. As I mentioned before, Professor Jules White, who has joined us from Virginia Tech, will be teaching the CS 278 class. And we're hoping to coordinate some of the work we're doing here with what he's doing. So he's going to be focusing on kind of cloud computing. It's nominally a software engineering course, but he's going to be doing it in the context of mobile devices and cloud computing and so on. In this class, we're primarily going to be focusing on the server side of the mobile phone programming. There'll be a little bit of client-side stuff, just because otherwise you can't get input to your server part. But we're going to be focusing primarily on that stuff. But we're hoping to team up with him and his class to do some projects that span both courses, which will be really fun, because that way we can build kind of end-to-end solutions. Where all of this is headed is something that is really exciting. Those of you who were around last year might remember that during the spring, when I was teaching CS 251, I was also teaching or proctoring a MOOC, a massive open online course, on basically pattern-oriented software architecture for concurrent and networked software. And this particular MOOC was something that was related to a couple courses that we've done here. It has some parts in it that are very CS251 related. We have an expression tree application, series of videos that illustrate how all this stuff works. If you go to the Coursera website and look under the POSA course, you'll find all the material, and we've got all these different video lectures and so on. And some stuff was sort of CS251 related. There's also a bunch of other stuff in there that's related to CS282. And in fact, I'll point you to some of the videos if you're interested. We're going to talk about Android here in a second. And there's a bunch of stuff. You can watch some videos that are not unlike what I'm about to present. So you can go back and watch those things and see really super high-end production, way better than what we'll do with the setup we have here. But the point was we recorded these videos and we used them as supplemental material for the class we were doing in CS251 last fall. So this semester, we're doing something a little different. We're going to be recording all this material, but the real purpose here is to basically build up a library of modules, and then we're going to use these things for next spring's redo or next incarnation of the POSA MOOC. Except it's going to be something unlike anything anybody has tried before. We're actually going to do the world's first trans-institutional MOOC. So the first half of that MOOC will be done by Dr. Adam Porter at the University of Maryland, College Park, and he's going to do a 10-week Coursera course where he's going to focus primarily on the user interface portions of programming Android. And his class is actually going on as we speak. He's starting in a week or so at Maryland. And so he's going to be recording videos based on the class he's teaching this fall, and that will then become part of the MOOC that gets taught in the spring. And then we're doing the same thing. We're going to create videos that will span 282 and 278, and then we're going to do another MOOC, 10-week MOOC, starting in March when his ends. And so if you were to follow both MOOCs, you would get 20 weeks worth of coverage that would be essentially soup to nuts on programming mobile devices and connecting them to the cloud. And nobody's ever tried this before. It's a really interesting example of the kinds of things you can do if you've got access to a MOOC platform. Because in real life, nobody would start the semester at College Park and take 10 weeks worth of something and then transfer to Vanderbilt and finish off the semester. That would just be impractical. But through the power of digital media and digital learning platforms, we can do that kind of stuff. So a lot of what we're creating here is the raw material that we fed in to that project and that course. What we're also going to try to do is build some prototypes of the apps we're going to use for the MOOC, and then make sure everything works, we understand how they work, and then we'll give them as assignments to the people who take that class. And that should be kind of fun. Okay, so that's just a little background, a little bit about the class. Anybody who's taken 251 before, this is not a whole big surprise. It's much the same kind of a structure. So what's the big deal with mobile devices and what's the big deal with Android? Well, unless you're stuck in a mainframe data center chained to a IBM 370 computer or something hideous like that, the world is going mobile. And it's amazing how fast this is taking place. If you take a look, the last couple of years, people are now buying way more mobile devices, and by that I mean smartphones and tablets and so on, mobile tablets, compared to traditional desktop computers. Just look at the stock prices of the companies involved and you'll see what's going on, right? It's amazing. A lot of the companies that in the past made their money building desktop computers or even laptops are just getting crushed, and their sales are down, and people who supply their ecosystem are being affected. Sort of the Wintel market is really under a lot of pressure, and it's largely coming from the iPhone and the iPad and the Android devices that do more or less the same kind of thing. So all the different tablets and smartphones. So clearly there's something big going on here, and I think this is absolutely the greatest evolution I've ever seen since I've been a professor, which is quite a long time at this point. And one reason why it's so exciting is you now finally have something that's a form factor that you literally hold in the palm of your hands, but it can do pretty much everything we've always expected computers to want to do. So you can do computation on it. You can do user interface presentation and display and input, human-computer interaction. You can do networking on these things. You can do concurrency. You can do persistent storage and databases. So pretty much any topic you can think of in the computer science curriculum that you learn about, be it compilers, programming languages, operating systems, databases, user interfaces, it's all right here. And that is very much unprecedented. And then when you cross-cut that with the fact that you can also leverage all the cool mobile capabilities. That's the real thing. The various sensors, the GPS, the accelerometer, other things on the phone, other things you can connect to the phone through USB or through Bluetooth. It's really an amazing new fangled way of doing things, and we're kind of at the beginning of that whole change in the way that people do computing. And this is going to accelerate very rapidly. That's what this class is largely about. It's also, of course, worth pointing out that in order to do much of anything interesting, unless you're doing emergency disaster recovery out in a hurricane-ravaged region, you're going to connect to some fixed infrastructure and interact with services that live in the cloud. So that's the other piece of this, is the cloud dimension to the whole thing. So that's why mobile devices, they're pervasive. Everything that you need to know, for the most part, that's important in computer science and computer engineering and software somehow relates to this in one way or another. So then why pick Android? Well, one reason that you pick Android is that it's very quickly becoming the dominant technology for mobile devices. So I think this slide says greater than 50%. It's probably greater than 70% at this point. It's just basically running away with the market share. iPhone is still prominent, in fact, arguably more profitable, although that's changing to some extent as well. But Android is just absolutely everywhere. The way that they did it with the business model of essentially giving all the source code away and letting people who are hardware manufacturers take it and co-opt it to whatever they want to do with it has really given them a commanding lead. It's going to be hard to catch up with. Other technologies back in the day, somewhat ashamed to say, I still carry along my BlackBerry Tour, which is it's like running DOS basically. It's so old. They're going away. I mean, take a look. They're up for sale at this point. Windows has gone absolutely nowhere. We had the CEO of Microsoft here about 5 or 6 years ago, Steve Ballmer, and he actually gave a talk over at the law school. And it was so funny because everybody kept asking, what's the mobile strategy? What's the mobile strategy? And he just wanted to talk about PC sales. That's what he loves. That's what he knows about. And it shows, right? Microsoft is just getting beaten to a pulp in market share. It's very interesting. It's a good example of what people call the innovator's dilemma. If you read about Clayton Christensen's classic work on disruptive technologies, great case study in mine. So Android is obviously growing quickly. It's open source. You don't have to own any particular computer. You don't have to join a developer program. As long as you have access, to a laptop of some kind, you can build your apps, and you can get them out to the world in various ways. For my money, it's also easier to learn than a lot of the other platforms. So I'm a C++ programmer. Have been a C++ programmer for about 25 years now, going way, way back into the early days of C++. I love C++. We still teach C++ in CS 251. But I have to admit, after spending time with Java, it is way easier to program than C++. And I think one of the things you'll have when you start really doing some of the development here is just some really cool Java features, the concept of anonymous inner classes and anonymous objects, and the ability to sort of define button click handlers just by subclassing and filling in a method. It's just very, very lightweight syntactically, which is refreshing and really cool. And now, this hasn't quite gotten to the point where it's ubiquitous yet, but as Java starts adding more and more cool features as well, it has many of the same things that C++ does. So it's got template-like support, not as cool as C++ templates, but it's soon, or has already gotten support for things like lambdas, which is a cool C++ 11 feature. So the good news is, if you take CS 251, especially the versions we're going to start teaching henceforth, you'll get a real good grounding in C++ and C++ 11. And if you take CS 282, you'll get a real good grounding in advanced Java and how you can use it for concurrent and network software. It's also way easier to learn than Objective-C, at least from my point of view. Objective-C, to me, is just the most bizarre combination of the ugliness of Smalltalk and C put together in some incomprehensible gobbledygook. And I find Java personally much, much easier to use. Okay, so that's kind of an overview of the course, some of the logistics, some of the administrivia. Does anybody have any questions so far? Okay. So let's talk about Android. So what is Android, first of all? Well, Android is largely a software stack, and it provides a bunch of things in that stack. It provides an operating system, it provides a couple of different layers of middleware, and it provides various services and applications. One of the things we'll talk about later is the fact that you can download the source code to Android, and I'll give you the link here in a minute. If you haven't gotten the source code to Android, go out and get it. It is absolutely fascinating to look at all that code. And there's lots and lots and lots of applications that come bundled with the software that you can look at to learn how Android application development works. They're way more sophisticated than the kinds of things we're likely to do in this course, but you'll find an amazing amount of insight that's bundled up in the packages, apps, applications for things like email, calendar, contacts, lots and lots and lots of stuff. There's also a software development kit, an SDK, that contains libraries and development tools for creating various kinds of apps. And you'll get exposed to that probably through Eclipse, perhaps through IntelliJ. You can see just by looking at this picture that there's some layers going on here, and I'll go through those layers shortly. We're going to be using the Eclipse Integrated Development Environment, or IDE, is our primary way. That's what I'm going to be using. You guys are welcome to use something else. The further you guys stray from what we use, the harder it may be to get support. But let me ask, Nick, what do you typically use? Are you an Eclipse user? Eclipse. Okay. And so basically, if you stick with Eclipse, we can help you, but you're welcome to use other stuff. When we did some projects a couple summers ago, did you use Eclipse or did you use IntelliJ, Richard?
I used IntelliJ
okay.
and Eclipse and a couple others. Eclipse is by far the most supported. So.
I think you guys used them because it was just less resource consumptive, right? IntelliJ was less resource. So if you have a slower laptop, that might be good. There's a whole pile of cool things that Eclipse gives you, and I'll show you some examples of that. Actually, let me switch over there and show you that right now. So here is, well, this is the Eclipse development environment. It's not the way I would normally look at it because the screen resolution changed to be fitting on the projector, so it's usually much tighter resolution. But if you've used Eclipse before, you're probably familiar with this. I think it's used pretty widely in 101 and 201 now. But basically you have something called a package, and that has a bunch of things in it. The most interesting part from our point of view is the source code, and there's also some other resources that are provided, things that deal with how the information's laid out on the display, things that keep track of mapping symbols to strings and other types of data, other assets that you might want to have, and so on and so forth. So there's a bunch of things you have there. If you go in here, you can click around and bring up the files you want to edit. One of the great things about Eclipse, if you've used it, is you don't really have to compile anything. It sort of does it in the background. As you make changes to the code, it does incremental compiling and linking, and so when you're ready to go, you're just ready to go, and you can go ahead and run your apps. There's a bunch of other things which we'll cover in more detail on Monday about how to set up your virtual machine, how to set up your Android emulator, how to get the packages that you want for the SDKs that you want. We'll go over all that stuff on Monday. And then once you do all that stuff and you know the magic, you can run your applications. For something else that I've been doing, anybody who's taken CS 251 will recognize this. This is the expression tree calculator program written with Eclipse. So now we have an Eclipse version of all this stuff. And what's particularly cool about this project, and I just got done doing this over the summer with some help from some other students who were working as interns over the summer, we rewrote everything in Java, it's no longer in C++, using basically all the same patterns, and we provided both command line and Eclipse versions of the interface with basically 99% of the same code in common. So it was a great example of how if you follow patterns, especially patterns like strategy, you can parameterize your code and have it run in different environments. So it's a little hard to show here because the emulator is big, but we can use it to do various kinds of things. So that's the cool part about using the emulators in Android. You can, or in Eclipse, you don't need the phone. You can go in there, you can debug, you can set breakpoints, and lots of other kinds of things you can do. So that's what we'll be covering next time, and you'll get a chance to come up to speed on all that kind of stuff. Okay. here's the quick and dirty overview on how to set up Android. I will just give this to you right now, and then later on we will cover this next week on Monday's class. We'll go through this in detail, and we'll cover other aspects of doing everything that I'm about to talk about. So if you go here, you'll download the first lab. The first lab is just to install and make sure everything's working. Used to be somewhat convoluted to set up Android. It's gotten to be absolutely ridiculously easy at this point. Pretty much all you do is you go to this website, which we list here, and just download the SDK, and it comes down in a zip file, and you unzip it, and you're basically ready to go. There's a few other subtle things, but there's not a whole lot more to it than that. So that makes life very easy. And Android doesn't quite work yet with Java 7, but I wouldn't be surprised if that would start to work fairly soon. And another thing you probably want to do is, if you have an Intel machine, and probably most of you do, as a laptop, you can set up virtualization so that you can have the hardware accelerated version of the emulator. And as I said before, that is way, way faster than the one that tries to emulate the instructions. I guess it's the ARM instruction set in software, which is ghastly slow. It took me a little bit to figure out how to do this, because I had to go out and set some fields in my BIOS, set the security properties correctly in the BIOS on my computer, and reboot the computer a couple times. If you Google how to do this, you'll find it, or you can follow the instructions, and we'll go over that on Monday with you in class. So feel free to bring your laptop and use it on Monday. So that's the first thing you got to do, get this set up. Many of you may already have it set up. The next thing is how do you program all this stuff? Well, mercifully, Android is very well documented. There's lots of Java documentation available at the Android developer website. So if you go to these URLs, you'll find all kinds of useful stuff. And in general, I find it pretty well understood, understandable. And one thing that they do with Android is that all the classes that are written are all self-documented using Javadoc style comments. And so they actually just take the source code and they run it through the tool, and out pops all the documentation, and then you can just get that from the web. For the things that take more than just reading the document or reading class definitions and so on, I recommend you take a look at some books on Android. What I've been using in the past is something I think actually you turned us onto. Somebody did. Was it Christoph? Yeah, it's called the Busy Coder's Guide to Android Development, and it's essentially an ebook. So you can buy the book and download it. You get a PDF from the author. It's like $40 along those lines, and he puts out periodic updates, and it's really quite helpful. There's a website where all the examples are available. You can download the examples, you can play with them, a lot of open source stuff. So that's what I learned when I did the class last time. I basically went through the book and used it to get me up to speed with what needed to be done to learn other stuff in Android. It's a pretty thick book, and there's a lot of stuff in there we're not going to spend a lot of time on, like fragments, for example, which are very cool but are kind of beyond the scope of what we're going to do here. But there's also coverage of things we will talk about. So services, content providers, SQLite. We'll cover a little bit of time on activities to learn about how to interact with the user interface. So good resource. Not the only resource. There's a couple other books out there as well that cover this, so feel free to look around. You can probably find a lot of free stuff on the web to learn as well. Okay, so that's just kind of an overview of a little deeper dive into the technical part. Let's now talk about Android itself. So what is Android? Well, Android is basically a layered software stack. I guess by definition a stack is layered, so that's somewhat redundant. But it's customized for the quirks and constraints of mobile device software. If you're interested in learning more about this, I recommend you take a look at Google I/O. So you go here and you say, let's see, Dan Bornstein Dalvik. There we go. Look at that. And if you go here and you go to Dalvik is the name of a little village, I think in Finland perhaps, or Iceland. I think it's in Iceland actually. And I think Dan Bornstein was from Iceland. or some of his ancestors were from Iceland. And so basically, he has a nice video. Let's see if I can find it. If it's not here, it is undoubtedly, here we go, there. So Dalvik Virtual Machine internals. And if you go watch this video, you will find out a lot of stuff, probably a little bit out of date at this point because it's about 5 years old, which is an eternity in mobile phone years. But it'll give you some of the rationale for why Dalvik is the way it is, and some of the interesting things that they faced when developing the software and some of the solutions they came up with when they did it. I'm not going to talk about that right now. We may cover it later in the course. It's a little bit lower level than what we're going to focus on, but it's interesting to understand, and is certainly one point in the design space for trying to attack these problems. So obviously at the very lowest level is a bunch of hardware, and that's this kind of stuff. And then on top of that is a modified version of the Linux kernel. And we're going to go into this in a bit more detail in a second, but for the moment, the main thing that they did in Android was they optimized the use of Linux for battery-powered embedded systems. So there's a lot of stuff in there about trying to do power management. There's a lot of stuff in there about trying to add certain capabilities that are optimized for device process-to-process communication, because that's a big important thing in Android because of the way the architecture works. So local inter-process communication is a big deal. Power management is a big deal. Trying to reduce footprint is a big deal. And so that's kind of the way that they tweaked Linux in order to work in that environment. And of course, all that code is in C. And you can actually go and download that code and play with it and tweak it and stuff like that. It's all open source. On top of that is an optimized Java virtual machine called Dalvik, a subset of the Java class libraries that run on top of Dalvik, some native C and C++ libraries, and something called a hardware abstraction layer. We're going to talk about all these things in a bit more detail in just a second. But the main thing to note here is that most of this code is written in C and C++. So the Java virtual machine, or the Dalvik virtual machine that runs on Android, is all written in C. It's quite interesting to take a look. I've read parts of the code before. Lots and lots of other stuff is done through native code. In fact, the way that you get performance in these environments is often by putting the real processing-centric or processing-intensive portions of the code and writing them in C and C++, and then wrapping a thin Java veneer around them. So we'll talk about some of those things. The hardware abstraction layer plays a very interesting role. One goal is to make it easier for people who want to have proprietary hardware to integrate their solutions into Android without running afoul of some of the licensing constraints that come with the use of the GNU public license that comes with Linux. We'll talk about that some more in a second. Then there's a whole pile of middleware layers. We'll talk about some more of them shortly. They handle things like the user interface interaction. They handle wrapping the telephony services, the radio, the communication that takes place over the cellular network. There's obviously lots and lots of support for multimedia devices, things like cameras, video cameras, taking still pictures, media players, things like that. And then there's a whole pile of things that are called app frameworks. So these would be things like managing the download of Android packages, which is how you get an application installed on your phone. There's a package manager to deal with that. There's obviously other things that are used to manage other resources on the phone, like the windowing system, managing the way that windows are displayed and rendered. There's things in there for managing communication between their various processes and applications on the phone. It's a notification manager. There's a lot of stuff on there that takes advantage of the underlying support for location-aware processing, the location manager framework. Big deal with a phone, knowing where you are, being able to communicate that effectively within your privacy constraints and so on. So there's lots of frameworks that come along with the system, and then there's, on top of that, a common set of applications. Now, when you actually get an Android phone, like if you get an HTC phone, oftentimes the vendor, Samsung or HTC or Huawei or whoever it is, will bundle a bunch of things above and beyond what comes out of the box from Google. There'll be some stuff that'll be Google and some stuff that are provided by proprietary vendors. Unless you buy a so-called pure Android phone. So there's certain phones, like the Galaxy Nexus is one example, where they actually just kept it to the open source software that's available, plus the Google applications. So Google has a set of apps like Maps, I think YouTube Player, Books. There's a few other ones that they have as well that are kind of Gmail, that are kind of, their proprietary value-added capability. Those are not open source. If you're really ambitious, you can reverse engineer them and look at them. If you try that, you will discover that in some of the cases, they really go out of their way to obfuscate the code. For example, if you reverse engineer Gmail or you reverse engineer Google Maps, you'll find that the reverse engineered Java code that comes from the bytecode is incomprehensible because they've shrouded all the code and they've turned the method names that would normally be something meaningful into like A, B, AA, BB, AB, AB. That's what they all look like. So it's next to impossible to actually make sense of the code that you reverse engineer. That's not uncommon for things people are really trying to protect, like their map algorithms. So that's kind of the stack of Android. We're going to dive down into this in a little bit more detail in a second, but that's kind of the big picture view. For what we're doing in this class, primarily, we're going to be focusing on some of the key capabilities and components in the system and building systems programming capabilities as services or content providers we then use to hook in with some simple applications. Take a look at this website for lots and lots and lots and lots more about what I just described. So let's spend a little bit of time going through each piece of the architecture. Some of this stuff is just good to know. One of the other great things, again, about the mobile ecosystem and the mobile domain is that you can learn pretty much everything you need to know about computer software and computer science in one context. So, if you just want to focus on operating systems, if this was CS281, the operating systems class, we could teach CS281 entirely using the Linux version, the version of Linux that's running on Android. And in fact, you'd probably get even more interesting stuff than you would get if you just did a stock version of Linux on your laptop or your desktop, because there's certain extra value-added capabilities that they've added in to the Android version that are really interesting and go above and beyond what you'd normally find. So you could just do nothing but that. If you were taking EECE 276, which is the real-time and embedded systems course, again, you could use an Android way of accessing programmable hardware like Arduino or Raspberry Pi or other kinds of environments where you can program sensors and plug them in through Bluetooth or USB or other ports into the phone. So you can learn about all that kind of stuff entirely in the context of Android. We're hoping at some point we can motivate some of the other professors here at Vanderbilt to start shifting the courses that they're teaching in operating systems or embedded systems or graphics or whatever to use Android there as well, because that way people can kind of get a common experience and really begin to amortize the time investment in the various tools that you have to learn to do this stuff. So if you become an expert at Eclipse, for example, we'd like you to be able to take that expertise all the way through the curriculum so that you can really get a payback for learning how to do debugger, learning how to be able to do other kinds of things with the Eclipse environment. So, Linux kernel, written in C. If you want to amuse yourself, go Google, let's do this. Let's amuse ourselves briefly. Linus Torvalds C++ rant. So you can read Linus Torvalds' rant about why C++ is a horrible language, which I think is pretty funny. So he goes on and on and on. I won't bore you with it. The main issue there is that C++ is actually a great language, but maybe not for people who like to write code for operating system kernels, because they tend to be deeply suspicious of abstraction. And I've had people over the years at various places who are huge C fans and kernel hackers, and anything that has an actually they think C is probably a little bit too abstract. They'd rather be programming in assembly code, quite frankly. But C is a good compromise. So the Linux kernel, all the device drivers, all the other services we're about to talk about, all written in C. They provide all the things you'd come to expect from a normal operating system: memory management, process and thread management, inter-process communication and networking, various types of persistence, device driver framework, security model, and so on. That's just common, normal stuff. And then they also add a whole pile of Android-specific capabilities. There's support for highly optimized inter-process communication called the binder. We'll actually talk about the binder. You will get a chance, you'll actually get a lot of chances in the class to play around with binder mechanisms. And you'll be accessing it through something in Android called AIDL, the Android Interface Definition Language. And there's some really cool stuff that lurks in this space. It'll give us a chance to talk about patterns. It'll give us a chance to talk about frameworks. You get a chance to learn about inversion of control and all the other characteristics, domain-specific properties, hook methods, all the stuff that we've talked about in other classes you may have taken about frameworks, shows up in the binder environment. Really, really neat stuff. There's also support added for shared memory that's used sort of internally for certain things. There's a lot of support for power management added to the kernel to be able to manage the power wisely, because that's really important when you're dealing with battery-driven devices. Other things, one of the things that Android does is if you start to run out of memory, it starts to get draconian and go through and shut down applications and shut down activities, which are little pieces of applications, and other things, services and so on. And so you have to write your apps to be prepared at any given point in time to have the rug pulled out from underneath them. And we'll spend a lot of time talking about this in the context of lifecycle management and patterns for lifecycle management. For those of you who took CS 251, one of the topics we covered in there was the template method pattern. And you'll get a chance to see template method used quite extensively throughout Android for managing the life cycle of these activities and other services. Kernel debugger and logger, you will actually see some of this when you play around with this. You won't so much see the kernel debugger and logger unless you're really gung-ho, but you'll see loggers and debuggers and so on when you use Eclipse. And there are ways of actually being able to turn on the instrumentation to get this additional insight as to how things are working internally. Lots more stuff. If you go to this URL, you can find lots more information about using Linux in the Android context. Hardware abstraction layer. Again, I'm mentioning this not so much because we're going to do it, it's just useful to know it exists. It basically defines something unusual. Most times when people develop device driver capability, it's tucked inside the operating system kernel. So if you go back here and you look at Linux, you can see that it's got some stuff in there that deals with drivers like audio drivers, Wi-Fi driver, Bluetooth driver, camera driver, display driver, etc., etc., touch screen driver. And those things are implemented typically in very low-level C, and they plug directly into the operating system, and it manages the devices through those interfaces. And they're very tedious and error-prone to write. If you're using Linux, they're also required to be open source. So if you provide drivers that are part of the Linux kernel, because of the licensing model of the GNU public license, you have to release that code as open source code. Well, a lot of people are reluctant to do that. So Android provides something called the hardware abstraction layer that allows you to write, allows vendors to write device drivers that live in the user space, which is a weird place for device drivers to live. Device drivers typically live in the kernel, but they actually run in the user space, and they're used for a variety of purposes, the most perhaps important of which is people who write device drivers in user space don't have to give the code away, because they're not licensed with the GNU public license. So the way that they explain it in the documentation is largely, not everything can be easily expressed through kernel level interfaces. They're rather low level, clunky, blah, 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 which is true. But the real reason is because they wanted to make sure that people would use Android for capabilities they were not comfortable releasing to the external world. So a lot of the stuff you might have for super high-end multimedia stuff, cameras, location services, all this other thing that may be very proprietary to either vendors or service providers, those things would be developed using the hardware abstraction layer capabilities, not the underlying kernel device drivers. We are not going to cover that topic. There are people around here who really have deep knowledge of that. If you're curious to learn more about driver kind of work or native development work, some of the folks, in fact, Zach McCormick will be here on Monday. He'll be talking about some things, and he's one of the gurus on that topic. There's a really nice description about the hardware abstraction layer you can download at this URL. It's worth taking a look at. On top of the operating system and on top of the hardware abstraction layer are basically the native C and C++ system service libraries. So there's a bunch of the things here. They have stuff in there that basically provides you with libc, which is the standard C library, APIs, things like fopen, fclose, other things that interact with the operating system and the system libraries. There's a media framework that's provided at this level for streaming audio and video. These are used by things like the multimedia players, the media players. There's something called WebKit, which is actually an open source web browser and rendering framework that Apple released back in the day, and that's available on Android. So somewhat ironic given the legal struggles between Apple and the Android providers that they're all using the open source Apple version of browsers. Something called SQLite, which is a database that's used for lots of stuff. We'll get a bunch of experience later on in the course doing things with SQLite. Most things in Android that have to live persistently, not everything, but most things that have to live persistently tend to be expressed using SQLite. So email messages, MMS messages, SMS messages, lots and lots of stuff have an SQLite. Contacts, calendar, all that stuff live in SQL tables on the device. There's ways of programming secure sockets, there's graphics engines, surface manager, and so on. By the way, speaking of Apple, and here's where you can learn more about native development. Speaking of Apple, if you get a chance, you might want to wait till this comes on Netflix. You should see the Steve Jobs movie, the one that just came out last weekend. I went and watched it. I've always been a big Steve Jobs fan, and it's pretty well done. Once you get used to Ashton Kutcher being Steve Jobs, you know, he actually looks a lot like Steve Jobs. Not quite so sure he sounds like Steve Jobs, but he looks like Steve Jobs, and he's got the mannerisms down pat. It's great the way he put himself in that role. Got a lot of good quotes, got a lot of good Steve Jobs quotes. Steve Jobs said a lot of quotable things. If you also have a chance, you should really watch Steve Jobs' commencement talk at Stanford. I think this was 2005, maybe around that time frame. It's great. He talks about, you know, sort of 3 things that shaped his life, and he's got a lot of wise things to say. What was most bizarre about the Steve Jobs movie is that the movie kind of ends just when it gets interesting in my mind, right? So it ends when he comes back to Apple, which is in the mid-90s. And if you didn't know anything about Steve Jobs and you watched this movie, if you got rescued from like Tom Cruise in Castaway, or Tom Hanks from Castaway, you came back and you've been out of touch for 30 years, you'd be like, why did they make a movie about this guy? Because mostly it's him kind of failing at Apple the first time, and then somehow miraculously they give him the job back. But you're like, well, why did they give him the job back? So if you don't know the rest of the story, it doesn't make a whole lot of sense. But it's an interesting movie, and he certainly had a big impact on things. Another set of things that they have in Android is the Android Runtime. This is basically Dalvik, and it's the class libraries. So as you undoubtedly know, Android applications are developed using Java, but they don't run in a standard Java virtual machine, which, by the way, was the subject of a whole other lawsuit between Oracle and Google back in the day after Oracle bought Sun. And they run in their own virtual machine, and the virtual machine is called Dalvik. And what they do is they take bytecode that's written in Java bytecode, and they convert it into the format that's run in the context of Android, which is something called DEX, which stands for Dalvik Executable. And the particular details, which if you were curious about, go watch the Daniel Bornstein video from Google I/O 2008. He talks about why they do what they do. They use what's a so-called a register machine as opposed to a stack machine, and he gives a motivation for why they do that. It has to do with trying to conserve power. They think they can make it execute faster. They think it'll take up less space, et cetera, et cetera. So there's a bunch of reasons there. In the early days of Android, first couple releases, they only had the execution of the bytecode in the form of DEX. In more recent versions, they've added support for a just-in-time compiler. So you would get the same benefits of just-in-time compilation with Dalvik that you would get with normal Java virtual machines that have just-in-time compilers. Just-in-time compilers basically take a look at the execution profile of the bytecode, and they rewrite it in real time and then have you execute the executable code as opposed to execute the bytecode, so it's faster. Apps typically run in their own instances. inside their own Dalvik apps typically run in their own processes inside their own Dalvik VM instances. So we'll look at some pictures of this a little bit later on as we get further into the Android architecture. But essentially, when you run an app, it's running in a separate Linux process, and inside that Linux process are a bunch of things. You've got libc, which is the C level libraries, that's the native code. You've got the Dalvik virtual machine, which is written in C, making libc calls. And then you've got the core libraries, which we're going to talk about in a second. And then you've got activities and other stuff that would come from whatever you're running, a browser, an email application, or whatnot. So there's actually quite a lot of stuff going on there. And if you take a look, there's another fantastic presentation, which I think I list here in a second, so I won't take you to it, called The Anatomy and Physiology of Android. And you should take a look at that. It's a Google I/O 2008, 2007 talk. Probably out of date in a lot of ways, but it does a great job of explaining the architecture. And they spend a lot of time trying to figure out how to optimize startup time. And they do some really cool things. They have a whole process mechanism called the zygote. And they load everything into the zygote process when the system boots up. And then whenever they want to start a new app, they simply do a virtual fork or a V-fork of the zygote process, which does a copy on write optimization of all the data and all the instructions in that process. And then they just load in the particular app's entry point for the activity that starts, and away it goes. So this is, again, heavily optimized for resource-constrained environments and embedded systems for smartphones. Lots more stuff you can learn about here regarding Dalvik. The core libraries, you get many of the libraries that are part of the normal Java class library, so java.lang.thread, and the sockets, java.net, this, that, and the other thing. You also get a whole pile more Android-specific stuff, and we'll talk about that. You'll get a chance to play around with some of that stuff. You also get other things that are kind of bundled along with this, so various Apache libraries for doing web operations and web service access and so on. But you don't get everything there. And if you want to learn more about this, take a look at this link, and it'll give you a comparison of the normal JVM Java class libraries and the versions that are in Android. On top of all this stuff are a set of application frameworks. This is where it really gets interesting in my mind, because now we're getting closer to the kinds of things we're actually going to be doing in this course. We're going to be leveraging some of this stuff, and we're going to be taking it and extending it in different kinds of ways. Once again, I'm not going to talk about all these things. We'll cover a lot of this stuff later. We'll cover content providers, for example. There's Window Manager that manages how you interact with a user through displays. There's a Package Manager, which is how you download apps from an app store or some other location, like your Eclipse environment, into the phone itself so it can run. There's a Telephony Manager that's used to actually manage the state of the phone. Is it busy? Is it ringing? Etc. It's also what's used for interacting with cellular services like SMS and MMS. There's a Location Manager that keeps track of where you are, using various capabilities that are interacting with the services provided by your network provider, and other stuff as well along those lines. Lots of good stuff you can learn about here. And then out of the box, you get a bunch of applications. And these are all available in open source form from the Android website I'll show you in a second. So you get things like Contacts, which is obviously very useful, Calendar to keep track of events, and you have different ways you can either use the Gmail versions of these things or the Microsoft Exchange variant of this stuff. There's camera applications, take pictures, take videos, so on. Your phone, of course, browser. There's an email reader that comes on the phone by default. Most people probably get Gmail and use that, but there's also an email reader if you don't choose to use Gmail. Media player, instant messaging, and so on and so forth. Really, really interesting to look at this code, and you'll get to see how the various parts are broken up, and we'll talk about a lot of that stuff as we go through here. All the apps that I just mentioned here are all written in Java, but large portions of these apps, or the implementations of the pieces of the framework that these apps use, are often implemented in C and C++. And the idea there is to try to give people the best of all possible worlds. So you get the convenience of Java programming, which is arguably a lot easier than learning and using C++ or C, but you get largely the performance of C++ and C because most of the actual work is done in C and C++ code. So that makes life a little bit easier, so you get the best of both worlds. What I'd like to do now is talk just a little bit about the various components, the key architectural components that are part of Android. What we're about to talk about now is what we're going to focus on the bulk of this course. And you'll see also, depending on how we end up doing the assignments, there's an application that you'll get a chance to start working on very shortly, starting next week, that will give you experience and exposure to all these kinds of things. And I'll show you bits and pieces of the app as we go through this. Basically what the app lets you do is you type in a URL for some place that has an image, and it downloads the image and stores it, and then it displays it. So it's pretty simple, but it illustrates some of the key points we want to get across in the class, like concurrent programming, running things as background services, accessing content across the network using various network and service capabilities, and then later on as we get further along in this thing, storing the information in a database and being able to access it through database operations like cursors and SQLite and content providers. The way in which you interact with the outside world, the user, is through something called an activity. And an activity represents a single screen with a user interface. Applications themselves may be composed of many activities. In fact, if you start playing around with Android for any length of time, you very quickly realize that lots of this stuff all works together. And you'll get a chance to play around, if you have not already, a little bit, because it's not really the main focus of the course, with ways of being able to have activities interacting with each other. So you have an activity that's going to start something up, prompt the user for something, based on what they provide, will then go ahead and create another activity which does something else, like look up the user in a contacts list or something like that. The typical way you do this is by creating a very important object in Android, probably one of the single most important things in all of Android, the intent. And an intent is basically an object or a data structure that keeps track of a bunch of things. It keeps track of data, it keeps track of the category of intent that it is, it keeps track of other extras that you need that get used as the intent flows around throughout the system. And the way you launch applications is by starting their main activity, by calling start activity, passing in the intent for what it is you want to create. And we'll talk a lot more about this later. There's different ways to create intents. You can name them explicitly, or you can give them properties or characteristics and have the system figure out which one is best for you. And if it can't figure out what's the best one for you, it'll pop up a little menu, and you can give it some hints. Oh, I really want to run this version of a browser, or I want to run this way of being able to handle an email or a text message or something like that. Applications have multiple activities typically. They could just have one, but they often have multiple ones. And there's lots of information available here to learn more about activities. This course is not going to focus a lot on activities, but you have to know enough of it to be able to do the application, otherwise you'll be hopelessly lost. The next thing, the next architectural component that's crucial in Android is called a service. And a service is intended to run in the background. Now what that means depends on a variety of different configuration parameters that you can set by a special declarative mechanism called a manifest file, or an Android manifest file. But basically the service runs sort of in the background, and it's intended to be used for longer running operations. Things where you may end up having to download something from across the network. Thing where you might want to be able to do some long running computation. One of the things you learn very quickly in Android, because if you don't learn it, it comes back to bite you very quickly, is that you only have a few seconds worth of time to wait when you're interacting with an activity. The activity has to be responsive, and if things take too long to run, a little dialog box pops up and says, application not responding. It's even got its own acronym, ANR, application not responding. You get an ANR message. And the ANR message is a bad thing to get. It's kind of equivalent in Windows or the Mac to getting that hourglass symbol. It says, you know, I did something wrong, something's hanging. And so you want to design your applications to not hang. So we're going to talk about how you can use services and threads and other mechanisms to run things in the background so they don't interfere with what's happening in the foreground. There's a couple different kinds of services. The easiest kind of service is something called a started service. And as you might expect, you start a started service by calling start service, and you pass it an intent, and it goes ahead and starts the service. These are often used for sort of one-shot services. They're intended to be run once. You pass parameters to them through the intent that's used to start them. There's another kind of service as well called a bound service. And they're a bit more like a daemon in the classic Unix networking sense. These things are intended to be started, and they will run for some period of time, and you can control how long they run. And they offer a client-server interface with the client. And so the client can sit there and send requests to the service, and the service sits there like a server and handles the requests and then may send results back. The way you typically interact with it is a variety of different ways. You can pass messages, you can use AIDL. We'll go through examples of all those things. You'll get a chance to play with them all by the time we're done. My preferred way of doing it most of the time is actually to use asynchronous callback-driven AIDL interfaces. And we'll talk a lot more later about why we do that. There's a whole set of patterns that are involved in doing this. And the basic idea is to set up your applications so that they never block, even if the call you make to a service takes a long time to run. And so we'll look at that, some pretty cool stuff. That will also give you a chance to learn about the binder as well. Next important capability is the concept of a content provider, which is used to manage data that's shared or potentially shared between multiple applications. A good example of something that would be accessed via a content provider would be something like the contacts database, which is accessed by lots of different things, or the calendar database, or maybe email, or browser history. There's a bunch of things that you could have different applications want to have a way to access. The data itself is typically stored in an SQLite database, and you'll access it using the SQLite programming API, and we'll learn a lot more about that. Very powerful, actually very, very powerful, because one of the things you can do with all this stuff that makes it a lot more useful than just using files is you can do query operations, and you can use pretty much the full-blown SQL query language operators and other kinds of things. And if you take a look at the Android source code, you will discover immensely powerful ways in which people leverage the SQLite query capabilities to look stuff up. So things like search history and other kinds of search capabilities that are built into all the apps on an Android phone use very powerful features in this space. You never access a content provider directly. You always access it indirectly through something called a content resolver, which is essentially a pattern, the proxy pattern, and you use this as a way to be able to mediate access to the content providers. And the last key architectural piece in Android is something called the broadcast receiver. And the broadcast receiver is a component that essentially responds to intents that are broadcast from other parts of the system. And it basically allows you to have a publish-subscribe-like model using the pub-sub, publish-subscribe pattern or the observer pattern or whatnot, where you can have different parts of the phone notify other parts of the phone that something that they may care about has just happened. The classic example of this would be when your battery starts to run low, and you want to be able to notify the battery manager, the guy that keeps track of battery capacity, needs to tell other parts of the phone, I'm running out of juice, you'd better do something. You'd better make the screen less bright, or you might want to shut down things that are consuming processing power like GPS devices and so on. And so they have a broadcast mechanism using a broadcast receiver to do that. Another cool thing that you can use with this is this concept of intent filtering. And you can have these complex intent filters. And this is used for a variety of different purposes throughout Android. And there's something called the Intents Framework, which is implemented by the Activity Manager Service, which is this big, smart, complex event processing engine that takes in the intents and it matches them against things that people have subscribed or registered for being interested in. And it's really, really powerful, really, really cool. We may or may not get a chance to look much about that in this course, but if you get the source code, you can play around with it. I should also mention that the person who's developed a lot of this software at Google, she did the Intents Framework, she did the binder stuff, has got a name that sounds like somebody from a Dick Tracy movie. Her name is Diane Hackborn. So what a cool name. If you're like this person who writes really great software, you're like Hackborn, like born to hack. I don't know whether that's her real name or not. It's kind of like Doug Hackworth, right? It's like, there's got to be a Dick Tracy villain there somewhere. Okay, so to summarize, and then I think we're doing really well on time here, Android defines a layered software stack. So if you are familiar with the layers pattern, which we've talked about a little tiny bit maybe in other courses, we'll cover it later here. It's basically a way of solving complex system complexities by breaking up things into independent layers that interoperate and integrate with each other. It's a layered software stack for mobile devices. Fix that. This is the place to go. Take a look at this website if you want to see the cool, hour-long video that goes through Android's architecture circa 2007, 2008. Some things have changed. The architectural parts are still very similar, and it's really, really good way to learn about the way that they optimize things for the environment in which they had to run back in those days. Android apps are developed using a set of framework components that Android can instantiate and run and shut down as needed. So it knows how to start these things up under the right circumstances. If for whatever reason you're running low on resources, it knows how to shut them down. One of the things that got to get your head around is the whole concept of life cycle. Things run. Android tells you when you can run or not, and so you are obliged to handle those things by callbacks. We'll talk later about the patterns that go through there. Lots of really, really cool, juicy patterns. In fact, that's one of the things, if you take 251 and then you take 282, you'll be amazed at the number of patterns you see that we talked about in 251 that show up in Android somewhere or another. Great example of a pattern-oriented, framework-driven, component-based framework or component-based environment for software. And most parts of Android are available in open source form. Here's where you can go to get the instructions for downloading the Android source code. You don't need it. If you don't download it, you're not going to fail the course. But it's not a bad thing to have access to, because you'll find that it's a good way to learn how other people have solved interesting problems. If you want to learn about how to do stuff that we'll be talking about later, like loader managers, or asynchronous query handlers, or binders, there's all kinds of cool stuff in there, and it's a good resource to have at your disposal to poke around at. It's rather vast though, so it's probably like 6 gigabytes worth of memory or disk space just for the source alone, but it'll really give you a sense of how it all fits together. Okay, so what you're on the hook for next time is to get your Android development environment installed, and then we'll start with a more systematic set of assignments that we'll work with from there. Any questions?